Hello everyone, welcome to Intellipaat live webinar on MongoDB. Today's webinar is conducted by Mr. Vijay Reddy, who is a senior DBA at Orbocom with 14 plus years of in-depth experience in managing database administration and development, big data and analytics implementing. He is excellent at designing, implementing and administering OLTP and OLAP databases and designing and archiving solutions. So guys, let's welcome Mr. Vijay Reddy Yerua into the session. Mr. Vijay, over to you, sir.
Hi everyone, I am Vijay. So today we'll be discussing on MongoDB and how MongoDB can help in enterprise applications. So we'll get an overview on the MongoDB. Let's start the webinar, and today we're going to talk about MongoDB. Again, it's not that easy or it's not that simple to cover the whole database in a session of in a single webinar. So learning database is a continuous process. You should continuously learn the databases, like if you're going to work on the databases. And in today's session, the agenda for the today's session is I'm going to give some introduction to the NoSQL databases and the types of NoSQL databases and what is NoSQL and what are the relational databases and when we should use NoSQL databases, in which cases these are very helpful. And then what is MongoDB and what are the MongoDB tools. So, and not full understanding about the MongoDB. To an extent, we'll try to understand where you can make use of the MongoDB. So this is the agenda for today. And so let's understand what is NoSQL. And as we all know that, NoSQL is like non-relational SQL. Like, there are two kinds of database systems, relational databases and non-relational databases. MongoDB falls in the non-relational database category. And Oracle, MySQL, and Microsoft SQL Server. So these are some of the databases that falls in relational databases. And in relational databases, mostly you store the structured data. So when we say structured data, so data will be in the form of tables with column names and then data types. And also you have multiple tables with, which have relations between tables to tables. Mostly you see a lot of relations in relational database between the tables. When I say between the tables, data inside the tables. And when it comes to the NoSQL databases, they allow you to store structured, semi-structured, unstructured, all kinds of data. A simple example for unstructured data or semi-structured data, if you people are aware of, of JSON or XML files, so those are the files, right? So documents, right? So you can store some data inside the document, right? So the data that you see in one document would be different in other documents, right? For example, if I open my folder, I have 4 documents here, right? So all these are the same type of documents, right? But the data that I see in one document will be different in the other document, right? Although their type is different. So here, when I start storing this data into the database, now each document has a different structure of the data. So it's a purely unstructured, right? So when you want to store unstructured data into the databases, so you will be storing the data in the form of documents. So MongoDB allows you to store the unstructured data in the form of the documents. Where in relational databases, you will be storing the structured data, which means all the data will be in the same structure. For example, if I want to store an employee information, for that entity, we'll be having columns, right? Like employee ID, first name, last name, phone number, email address, and all, right? So it's a fully structured. An entity have a full structure. So in relational databases, what you can do, you can store the data in the form of rows in a single table. Even if you have 1 million employees or 1 million employees information to be stored, since all this entity information is structured, so it will be very easy to store such huge amounts of data in relational databases. So relational databases allows you to store structured data. But what if you really wanted to store unstructured data? Like as I mentioned, I have thousands of resumes, okay? And each resume, the format, the content inside the resume will be different, right? So in the structure that you see in one resume, the structure will differ in the other resume, right? So when you want to store resumes into a database, That is not possible in the relational databases because they don't allow unstructured data. They don't allow you to even store the documents in the relational databases. So that's where MongoDB comes into picture, where it is a document database. It will allow you to store the documents, and then inside the document, you can have unstructured data, structured data, and also polymorphic data. We're going to discuss some examples on this thing as well. Now, as I mentioned, so MongoDB is a NoSQL database, right? And as I mentioned, you will be storing the documents and then columnar data. Like if you, and also if you have any data in the graph format, you can store all this columnar graph format and then documents inside the NoSQL databases. And that includes the key value also. We're going to discuss what is key values and what is documents and what is columnar format data. Let's take a key value pair database. I mean, key value, how you can store the key value inside SQL Server or inside MongoDB. When it comes to the key value, as I mentioned, employee details, right? So here, if you look at the employee data, you have an employee ID, right? And for that employee ID, you have set of other related columns, right? Like first name, last name, and address. So in this entity called employee details, I have attributes like employee ID, first name, last name, and address. Okay. And when it comes to the key value, you can see in the payments, there is another payments call a table, right? So there I have a payment ID, and each payment ID, for example, I have a payment ID 1, and the amount of 50 is being paid to employee ID 1 on this particular date. Now, here the key value pair is every row will be having an unique identifier. So for example, if I wanted to know about employee John, so there is an employee ID for that employee, right? The same way for each payment information, there is an associated ID, right? So this is the key. And for that key, these are the values. So in this structure, keys and values are paid together and get stored. So for each key, there is a value associated value, right? Now, if I really wanted to know what is the salary for, let's say, what are the payments that I've done for employee ID or employee name John, what I can do, I can get the value from this employee ID 1 key for that employee ID details for employee ID key. And also using the payment ID key, I can get the remaining values for that particular key. So you can store the data in key value pair in MongoDB. So this is how a key value pair data looks. And next, when we go to the document type, so as I told you that MongoDB allows you to store documents as well. For example, I'm going to show you some documents. So I have a, maybe not exactly this. Yeah, I can show you here itself in the page itself. So here, if you see, now you can see, right? For example, I want to store employee information. Now, when I get the employee information, for example, if you take an employee entity, if you know the defined structure, like for example, for this entity, I'm going to get data for these columns. Let's say employee ID, first name, last name, email ID, phone number. But sometimes what will happen, you might, I know if when you're gathering the data from various systems, like when you're gathering the data from various systems about employees, then there is a possibility that the data that you get from various systems will not be the same, right? I mean, from one system, if you get the data, might have only few fields, and the data that you get for the same entity from a different system might have some additional fields. So here, the data that you get from various sources is completely unstructured, right? It's not properly structured, right? So when you get the data like that, what you can do, you can convert that data into documents, okay? And inside the MongoDB, you can store that unstructured documents as a collections. For example, here, if you see, let's say I'm running an e-commerce portal, okay? So whenever I receive an order, okay, usually when we place an order, we'll be giving a lot of information when you place an order, right? So sometimes, in the field of address, when you want to give the address to deliver a product, sometimes what you do, you just give the in the address your name. You might not have an alternate phone number, and you might just give only the primary phone number. And when it comes to the first line, second line, third line, you might just give only the information in the first line, and then state, city, state, zip code. And if you want to give any kind of additional information, you can mention. So that will not be the same for every order, right? For a few orders, there will be a first line, second line, and third line in the address. So each order will have different information in that case. So what usually this kind of information can be captured as a document. Okay, something like this you can see here, right? So let's say if you take order ID 1001, now I'm capturing that order ID information in this documented format. Like I have a customer ID and order items and the product ID, quantity, and then cost. Now in this single product, I mean, let's take an example of 1001. So in this particular order, you can see the same customer had placed order on this particular date, but he placed order for two products. And in there is another order by customer ID 220. And in that order, he placed order for only one product on this particular date. So here you can see in the both the documents, we have different set of data, right? I mean, the structure of the data is not exactly the same, right? In the first document, in a single order, I have two products delivered, purchased on the same day. In the second order, there is only one product purchased in that particular order. So here, what I'm doing, for each order, I'm getting the data into a document. And then that document I'm storing inside the database by associating a key to that. So this way, this kind of data you cannot be able to store in the relational databases, because in relational databases, your data will be in the tabular format. So there, for example, let's say if I want to store the data for the same order for two products, what I need to do? I need to have two entries in the table. Two rows I have to create. So for example, this order ID is, let's say, 1001. So in relational databases, what will happen on the table? I'll have two entries for 1001 order. So in one row, I will be having information about product ID 2010 along with the quantity and the cost. And in the second row, I will be having the information about product ID 4365, quantity, and then cost. And then for the next order, that is 1002, because it is only a single product, then for that order, there will be a single row. So if we want to store the same data in the relational databases, in a table, I need to store this data across three rows. Okay, and again, what I need to do for each associated product in that order, I have to map a order ID. So that's how you store the data in the relational databases. So that's why there will be a relation. And also if you really wanted to know what is the customer information, that information will be there in a different table. So now when I really wanted to know that customer, that order complete details like order ID, customer name, first name, and the address that order has been delivered, I may have to join the data between orders table and customers table. Now when it comes to this NoSQL databases, I can put all that order information in a single document. I can store the document inside the database. And when I really wanted to query, I can query the database for the required data. Now in NoSQL databases, when you store the data in the documents, you cannot guarantee that each document will have the similar set of data. So that's why you can call this as unstructured data. So there is no guarantee that each document will have the same structure. Some in one document you might have more information, in other document you might have less information. So this is how you can store documents inside MongoDB, and this is how documents looks in MongoDB. And when it comes to the columnar databases, so for example, I have a data like this, like at 0 second value was 15.2. For example, I'm having a device, and that device, maybe I'm running some test on the device. When I start the device at 0th second, my value for that device is around 15.2. At the 10th second, value is 15.4, and 20th second, 15.7. Okay. Now, when it comes to the columnar databases will store the data in this format. So you will have a time column and value column. So in the time column, you will be storing all the times. In the value column, you will be storing all the values. Okay. And the purpose of using columnar databases. When it comes to the columnar databases, mostly Cassandra is a columnar database. So the main purpose of the columnar database is like it will let you write the data and also retrieve the data quickly. Why? Because you will be storing the all column data on a single, all the values related to on a single column. And also columnar databases will allow, if there are any unique values, instead of storing that value again and again, deduplicating the data, it can store the value as as a single value, and it can have mappings to that actual values. So that way, when you have a columnar databases, you can also reduce the size of your overall size of your data also, because if there are any duplicated values, they can get compressed and stored only once. So that's the benefit of columnar structure, and that kind of structure also can be stored in Mongo database. And graph databases are of more of representational purpose. Like if I really wanted to represent a relation, okay, or represent, for example, if any of you having knowledge on the databases and deadlocks, if you are someone of you working on the SQL Server database, when you really wanted to see the deadlock graph, you can see the graph, right? So which is the session ID and which is the blocker, and what is the victim of the deadlock, and all that information. So if I have any information in this representation, like the way that you represent the information in the graphs. So if I have graphical data, data in the graphical representation, which is not possible to store this graph data in the relational databases. Where in MongoDB, you can store the data in the graph representation as well. For example, in this, by looking at this graph, we can easily say that there is a relation, right? John is a friend of Sally and Sally is a friend of John. And then you can say John read the book about graph databases, and also Sally read the book about graph databases. So this single graph is giving a lot of information for us, right? Now, if I have any that information that is being shown in the graph, so we can store that information also on Mongo database. As I mentioned, as it allow you to store different structures of the databases, different structure of the data. So that's when you will be using MongoDB. That's why MongoDB is called as a NoSQL, non-structured database, relational databases. So in relational databases, you mostly store the structured data. Like you will have same structure of the data. So if you go to any table, you can see all the rows, all the data inside the table will be same structured. So there will be an entity will have attributes. But when it comes to the non-relation databases, you can, as it allows you to store unstructured data also, your data will be stored in the form of documents. So I'm going to show you how you can store the documents and all. Before that, let us understand the benefits of the NoSQL databases. Now, when it comes to the relational databases, I'm going to open an Excel file and make you understand this. So for example, I decided to use one of the relational databases, for example, Oracle. Now, when I want to set up an Oracle instance, what I need to have? I need to have a server, something like this. Now, inside this server, let's say I have 32, let's say 8 CPU, okay, and let's say 32 GB RAM. And you might have some 1 terabyte of disk space. Okay. Now, this is your server. Now, in this, you installed, let's say, Oracle database. Now, as I mentioned, Oracle is a relational database, right? It stores the data in the form of tables. So your data will be stored in the table. A table will have columns. Now, a database inside, a Oracle database have multiple schemas, and it can have multiple tables also. It can have several tables also. Now, all the data that you stored on those tables will be stored on a single server. Now, let's say for example, let's say in the year 2020, I have around some 100 tables, okay, and the size of those 100 tables around, let's say 800 GB. Okay. Now by 2021, you have an additional 120 tables there, and also your data size has increased by 970 GB. Now, what I need to do for the capacity planning for upcoming year, for the year 2022, as I know the data is going to grow, right? So in relational databases, when your database is growing, okay, and there is only one way that you can scale your database server, by vertically. Okay, means I can only increase the resources of this server. Maybe I can increase the CPU resources because now I have more data on the database, and in order to manage my workload, I need more CPU resources, and also I need to increase the RAM of my server. And also, since my data is growing, I need to extend my disk capacity also, right? So I can only extend the database vertically. Okay, that is one of the problem with the relational databases. Now this can be easily eliminated, which means if my database is growing, okay, if I'm adding more data and my database is keep increasing, and if I want to ensure the performance of my application, and if I want to ensure my performance of my application is always stable, and what I can do, if I am using MongoDB, I have the flexibility of scaling my MongoDB server or my MongoDB installation horizontally. What it means is, let's say, for example, I started a MongoDB server like this. Okay. I initially started with 4 CPUs with 16 GB RAM or maybe 8 GB RAM and 1 TB of disk space. Now, same, we'll use the same example. So I started in the year 2020. So by the time it reaches to end of 2020, I have 800 GB of data. Lot of data has been added. Now by the end of 2021, again more data has been added. My database size is increasing. Now, if I really wanted to scale this server, okay. Now you might have a question in your mind: why can't we scale the servers vertically? We can scale. I'm not saying we cannot scale servers vertically, but there is a limit also when you're scaling servers vertically. For example, if you're using virtualization, there are a lot of limits in the virtualization. You can only scale servers to an extent. If you're using any cloud services like Google Cloud or Amazon or Azure, there also when you're using an instant type, so once you reach to that level, you cannot go beyond that. Okay, you cannot scale vertically in some of the cloud providers also. So there is a limitation when you want to scale vertically. So that kind of problems you can avoid using Mongo database. Like for example, if I want to store the data inside a database, if I go ahead and start using Mongo database, as my data increases, right, I have the flexibility of adding more servers horizontally. For example, in 2022, I decided, I'm going to have more data. Then what I can do, instead of scaling up this server, I can build another server. Like this, I can have multiple nodes in a single cluster. So for example, I have 4 nodes here, right? So all these nodes can be a single MongoDB instance. All my data that I'm storing into the database will be stored across multiple nodes, will be distributed across multiple nodes. So this way, for example, in the year 2022, imagine that you have 2 terabyte of data or by end of 2022. Then what will happen? Since now you have 4 distributed, you have 4 nodes in this MongoDB cluster, and as it is a distributed database and it can scale horizontally, right? Since I added 4 clusters, I have the capability of sharding the data, which means my data of 1 TB, 2 terabyte can be stored across 4 nodes, 4 servers. So I'm also managing my workload. I'm also splitting my workload horizontally across multiple servers. So that way, it will also help me in terms of in performance improvement. Okay, majorly when you use databases, and database performance is all about how quickly you can retrieve the data and how quickly you can write the data, right? Now, if you are giving the same work to 4 servers instead of a one big server, that could improve the performance, right? So that benefit you get with the MongoDB. As it is a distributed database, you can add more number of nodes, and then you can distribute the load across multiple nodes. And also you can replicate the data in single each node. And if you further want to replicate the data for high availability, you can do that. So that one benefit that you get with the NoSQL databases. You can use this structure in Cassandra also. Many distributed database systems are NoSQL databases. And in relational databases, what happens is, if I have a data, for example, if I want to store employee information. So an employee information contains, information about an employee and the department that employee belongs to, right? Again, if I really wanted to know about each individual department information, that information will be stored on a different table. So mostly relational databases are normalized. So when the databases are normalized, you will have many tables and many related tables. And when you really wanted to get the data or meaningful reports, you may have to join multiple tables. Okay, why you do that in the in relational databases? When you normalize the data in relational databases, you can minimize the storage footprint. So when you reduce the storage, the amount of data that you're storing by avoiding the deduplication or duplication of the data, it will help you to improve the performance of the queries. But that will comes with a cost of joins. When I really wanted to see a meaningful data, I might need to join multiple tables together. Here in NoSQL databases, that's not a problem, right? Storage is very cheap these days. So I mean, and also since the data is fully unstructured, so you need not to keep all the information on a single table. You can break the down data into multiple tables, and also the data that you're storing on a table can be stored across multiple servers also, right? The data is also again distributed across multiple servers, right? So here you can store all the data that you required on a single table. So that way you can avoid joins also, because joins are very expensive. Like when you want to join the data from multiple data sets, it's expensive. So you can avoid joins on NoSQL databases by keeping all the data on a single table. So that's the reason most of the NoSQL databases will be used in analytical processing or data warehousing side. If you are having any kind of transactional database, like where you want to manage online transactions, where you require normalization because you want to quickly store the data by minimizing duplicates, so you will have to normalize the database. So in OLTP workloads, you will be mostly seeing people using relational databases. But in OLAP, databases like online processing, analytical processing, or data warehousing, you'll be mostly seeing NoSQL databases being used. So MongoDB will be a right fit in the data warehousing side. Again, as I mentioned, in relational databases, when you create a table, you have a structured, you have multiple data types and columns kind of stuff, right? So when it comes to the MongoDB, as it is a NoSQL database, you don't need to fit your data into a schema because you're storing the data in the form of documents. So inside a document, you can have many values or less values. Okay, inside your document, for example, going back to this example, so I'm storing two documents, right? So in one document, I have more information. In another document, I have less information. So still I'm able to store the document, right? Because my NoSQL is not having any schema there. So I'm not preparing a schema and I'm not inserting the data into that schema. So that's why NoSQL is a schema-less. So that's the reason you no need to fit the data for a schema. You don't need to prepare a schema and then fit data into that schema. So it's a schema-less. If you have documents, you can keep storing the documents in the MongoDB. And as it is very, there is no need of doing normalization. Okay, and there is no need of worrying about vertical scaling and all, right? MongoDB deployments are always quick and simple, and they are easy to deploy and they are easy to manage. And yeah, there is another benefit, that ability to cope up with the network failure. As for example, if you go with this relational approach where all your data will be on a single server, right? For example, if there is a network issue or if there is any kind of crash, now entire thing will be completely down, right? Wherein NoSQL, since you have multiple nodes, multiple data servers connected in a single cluster, even if one goes down, still others can serve the purpose because data also can get replicated between these nodes. For example, data that you stored on this node can also be replicated to this node. So since the data is getting replicated across multiple nodes, if there is any issue with the connectivity, or if there is any issue with one of the nodes, still you will be able to serve client request. That is one of the best benefit of no relational databases. I mean to say NoSQL databases. Along with performance, you can also cope up with this kind of failures that you see, like network failure, and or if there is a problem with one of the node, you still can be able to serve client request. And low latency and high performance, it's obvious because if everything running on a single server, if there are too many requests and if your CPUs and will be busy processing those requests, right? So there will be some requests waiting for those ongoing requests to complete. So definitely that could lead to latency, right? Wherein in distributed systems like MongoDB, since you have multiple nodes connected to the same cluster, when you get a request, for example, here, if I get a 200 request or 2000 request, and there are only 8 CPUs, right? So if let's say if each CPUs or each thread is handling and maybe some 100 queries are serving at this time, so remaining 1900 have to wait here, right? Wherein in the distributed system, if I see too much of workload, I can add many nodes. Okay, because I can scale vertically, horizontally, right? And also, if I'm getting 2000 requests, now what will happen? These 2000 requests will be distributed across multiple nodes. So since your load is getting distributed, obviously you can get the better performance, right? So usually NoSQL databases will give you low latency and also high performance because you are using distributed structure there. And as it can store any kind of data, right? So it can store multiple different data structures into the MongoDB, and it is very less management compared than other relational databases. So I'm going to give major differences between relational and non-relational. So as I told you, in relational databases, mostly data will be stored, in the table structures. Where in NoSQL databases, you can store the data in as documents or as graphs or as unstructured data. Also, you can store structured data, graph data, and when I say documents, you can have JSON data stored, XML data can be stored, Parquet data can be stored into the databases. And as I told you, MySQL, Microsoft SQL Server, and Oracle, these are the relational databases. And when it comes to Mongo database, NoSQL databases, you can finally find MongoDB, Cassandra, and then there are so many other NoSQL databases. And as I mentioned, if you want to store the data in the relational databases, you have to define the schema first. In non-relational databases, your schema is always dynamic because it can allow you to store any kind of data, right? So it's a schema-less. So that's why it allows you to store any kind of data. All right. And if you look at overall use case of the databases in real time, for example, I'm going to show you, like, if you go to this portal, which will tell you, overall how companies use different database systems by ranking. So if you just go to this link, you can see you will be seeing the most use case of relational only. You can see Oracle, MySQL, and Microsoft SQL. As you know that in real time, there will be a lot of OLTP processing happening. Okay. Mostly there will be a lot of systems like if you take an e-commerce portal or banking system, most of these are relational. They will be using relational databases for online transaction processing. And for data warehousing and analytical purpose, that's where you use NoSQL databases, right? So that's where the use will be little less. And in NoSQL databases, again, you see MongoDB always tops in that list. So I would say that if some of you are new to this database systems, if you really prefer to work on the databases, if you aim to be mostly like if you want to work on an analytical part, like if you want to become a data scientist, or if you want to become someone who can work on reporting side or preparing dashboard, something like that. So mostly this analytical processing will happen on the NoSQL databases. So you should know about Mongo database. So most of the time, I can in my environment also, in a lot of places we use NoSQL databases for what to say, analytical purpose. I mean, to analyze the data that we get, to make the decisions based on the data. We process the data and we store the data into the NoSQL databases. So we use MongoDB and Cassandra a lot in a lot of my implementations. And when it comes to the relational data, like when it comes to the online processing data. So to give you a basic example, for example, I'm working for an IoT company. So where we gather the data from lots of devices. So there will be a lot of devices running which are attached to these containers and ships and then trucks, trails and all, right? So we'll be receiving all the data and then we'll be processing the data and then we'll be showing the data to the customers. If somebody wants to know where their truck is going and where their ship container is moving, they can see the data by using our application. So what we do in this process, when we gather the data, right? And since we want to show that information immediately to the customer or to the client, so we process that data that we get from the device, and then we process the data and we store the data in a structured format in the OLTP databases. So in my environment, we mostly use all top four databases. Like we use Oracle, MySQL, Microsoft SQL, and Postgres in various projects to store all the structured data. I mean, processed data. And then what will happen on the processed data? We also need to do some kind of analytics. So if I go ahead and start writing queries, analytical queries, like if I want to see an aggregation, and if I want to perform aggregations on year of data, by month or by year or something like that, it will be very difficult to do those kind of things on the relational databases. So what we do further, we read the data from the relational databases according to our analytical requirements. We process the data and we convert the data into the documents. Okay, and then we store the documents inside the NoSQL databases. Now again, as I told you, you need not to store documents always. Even you can store unstructured data also. So in NoSQL databases also, I can store the data. In MongoDB, I can again create a table, and inside that I can store in each document single values. So you can store unstructured data, documented documents also. In my application, mostly what we use, so when we receive the data for a device, and then when we process the data for that particular device, right, when we want to do analytics by month, by week, by day, right, we process all the data for various durations, and we keep the data on a document, and then that document we store on MongoDB. And whenever we want to find any information for that particular device for any analytical processing, then we query that document and we get the data for that particular device from the document. So this way, I will be storing each device information as a document. Now, why I'm using MongoDB in this particular case? Because if I want to store the data, all the data for a device by year, by month, by day, by hour, like that aggregated data, then I need to have too many tables in my relational database. So when I have too many tables, when I want to see the data combined together, I'll have to do joins, right? So here, I don't want to do all that. I want to improve my query performance. And also I want to, as I'm going to load lots of years of data into the data warehouse, right? So my data warehouse database should be also good enough to scale. So here MongoDB gives me both. I can scale horizontally, and with low latency, I can improve my write performance and read performance, so I can get the better performance as well. So mostly you see all these relational databases being used for online transaction processing, for immediate processing of the data. And when you want to store the data for analytical processing, you'll be seeing making use of some of these NoSQL databases like MongoDB, Cassandra, and all. So this is some information I can give on the MongoDB. I mean, we'll be covering, like, if you're going to be part of Intellipaat. So we're gonna get. We're gonna discuss a lot about how you can do MongoDB clusters. How you can set up MongoDB clusters, and then when it comes to the sharding of the data, like when you want to distribute the data across multiple nodes, right? So how you can shard the data, and then what will be the sharding key, and then how you can take a decision on the sharding key, and in documents also when you're storing the documents. So how we can insert the data, update the data, delete the data into the documents. All those, we can experiment in the sessions. Once again, guys, thank you for your time. I hope I gave some insight on use case of MongoDB. Again, I thank you all for your time.
Yeah. Thank you, sir. Thank you very
Thank you.
much. It was a great session. It was very insightful. After this, we have Mr. Burhan with us. He is a career expert at Intellipaat. He is here to guide us on a little bit about MongoDB and big data as a career. So, Mr. Burhan, it's over to you. Let's listen to what you have to say.
Thank you. And again, thank you so much for the wonderful session, Mr. Vijay. I hope our students got to learn a lot about what exactly is MongoDB, and apart from that, how is the career as a data scientist or a big data engineer. Now, myself, Mohammad Burhan. I hope you all are doing well, and I'm one of the senior learning consultant here at Intellipaat. So, if at all being a student who is sitting there and planning how exactly if I can start my career in these technologies, and if you want some guidance and support from such well-experienced industry experts like Mr. Vijay and so many more, so I would be able to walk you through the courses what we deliver. And if you are interested or planning for anything in a technical field in IT, or if you're planning to look for a job or looking for a change or a start in career, of course, these courses and our guidance would be more than supportive for you. So I'll be just exploring or helping you out with whatever options we have at Intellipaat. And to introduce you about Intellipaat, all right. So yeah, this is the Big Data Masters program, and this is a website, intellipaat.com. You can see in the right-hand side, this is a combination of 13 courses together, and it's online classroom training, which is live interactive virtual classes conducted through a similar platform what we're using now, Zoom or GoToMeeting. And it's very highly interactive, meaning in the online paid courses what we offer, you'll be able to interact, unmute yourself, talk to the trainer, communicate properly, and there will be proper support also. So this is the course number one. I'll show you the curriculum first. So it has a combination of six courses, which is under I'm sorry, around seven courses, which is under online. So it doesn't have any such interconnection here, meaning you can directly start with any of the respective program as per your convenience. But if you're new to big data, or if you're new to big data or entirely into data engineering, we recommend you start from Big Data, Hadoop, and Spark. Then we have Apache Spark and Scala. These two are an important asset for a career in big data. And then we have Splunk Developer and Admin, which is a very popular log analytical tool used widely in banking or any other company. And then we have Python for data science. I mean, even if it is applied in data engineering or big data, Python will be also getting taught here. And Python is very important. Then we have PySpark. It's nothing but integrating Spark with the help of Python being the programming language rather than Scala. It's very, very advanced, and PySpark professionals are very highly paid and very much in need right now in India. Then we have the very most popular tool, which is MongoDB, a NoSQL database, and we will be teaching about MongoDB as well here. And finally, we end up with cloud big data, that is AWS big data. And as we all know, we are living in a data-driven world, and having knowledge about at least one public cloud platform, AWS, Azure, or GCP, is mandatory. And we are teaching about AWS here completely from the scratch, and complete data visualization and analytics on AWS cloud. So these are the top seven courses which is under online, and you can do it one by one. There is no such time restriction. The best part about Intellipaat is the entire training would be active and valid for lifetime, meaning these courses are not restricted, or we're not going to put a pressure saying that you need to do it in a year or you need to do it in 6 months or such. So you can take your own time. You can do the courses one by one, or you can do it parallelly, and you can take a pause in between. That is completely up to you. And based on your requirements, you can customize it. So apart from these courses, which is under online, we have these green color highlighted blue points, which is self-paced, which is provided as a complimentary, that goes with Hadoop testing, Apache Storm, Kafka, Cassandra, Java, and Linux, which is some elective courses which we have provided. Maybe in the future it might be useful for you, but to be able to represent yourself as a big data architect and qualify with whatever knowledge is required, these seven things are more than sufficient enough, and it will easily be able to get you a good opportunity in the future. So these are the combination of 13 courses here, and I'll tell you about the training methodology and the support what we offer. So now, who can apply for the course? Anybody, first of all, even freshers and undergraduates can apply for the course. They are most welcome, because we are going to start everything from the scratch. And even people working in MS SQL, or let's say people working in BI, or people already working in data science, but not all the tools of data science, they want to get wide knowledge about that particular profile. Or even software developers who are looking for a switch from their existing career and want to move into big data and connect the prior experience, or people who are already willing to build a career in big data, are most welcome here. This is open for everyone who has an interest. And once you are done with the training, these are the roles and responsibilities or designations which you can expect depending upon the profile or the company's requirement and other things. Being an application architect or a big data architect or an information architect, so you're going to be completely dealing with huge amount of data and making sure that you provide good proper information to the company with the help of your knowledge and whatever tools and technologies you have learned. And skills to master, there are a lot of things which we teach here, and we have put some of the skills which is quite popular, starting with Hadoop, HDFS, MapReduce, Spark, Pivots, ETL, and so many more. And you can also see the tools to master here. These are all some of the tools which is mentioned for a quick grab look at it. And yeah, now if you scroll down, this is the curriculum which we have already seen. And the main part here would be there would be like a lot of projects provided. If you can see in the curriculum, if we are learning about around 20 subjects or 23 modules in a particular subject, for every module there would be hands-on exercises, and you'll be able to implement whatever you're learning theoretically, so that there is no lack in practical exposure. And once you learn all of these particular subjects, then following up we'll be having real-time projects. And now these are all industry-oriented projects, which is use beginner level project, where initially if you're new to this particular technology, so you don't have a lot of pressure. So we start with the basic projects, and then we get into intermediate level of projects, and then we jump into the advanced level projects. So it has a certain category, and it's easier for you to catch up no matter whatever XYZ background you're coming from. And these are into different industry. We have into banking, we have into IT, we have into BP outsourcing, we have into analytics for a particular company, and so many other related industry-based projects would be there that would give you real-time experience, and it could be equivalent to 6 to 12 months of experience depending upon the number of projects you're doing. So when you appear in an interview, you'll not be someone who is new to the technology. You can showcase some experience in your resume or profile that would be easy for you to validate your skill set and answer the questions in the interviews as well. And in the technologies like data science or big data or cloud, it's quite necessary for you to have good qualification and good real-time experience. Experience is very important for you to crack the interview. So that would be able to achieve here. And these are the examples what we have. So we have many career transitions of our students. You can download the handbook also, and you can also hear the story from here. Now if you're a fresher who is looking for a career in data engineer, we have a very big example, Mr. Nischay Agarwal, who was a fresher and who had pursued one of these big data programs from us, and now he's earning a 30 LPA package, and that's not a small amount. And big data professionals are very highly paid in India, that one Morgan Stanley. So this is one example. And we also have a lot of other students who have here. Associate consultant Mr. Yogesh Kumar, from a consultant he had moved into a tech profile. And there are so many other examples. Depending upon your experience and your background, you can cross check and verify. And you can also check these profiles on LinkedIn to directly check their experience also. So this is the average salary hike what we see for a student who's coming from a technical background. And the highest package, we have 40 LPA for one of the students. Almost over the last 5 years, we have around these many amount of career transitions here, and we are tied up with almost 300 plus hiring partners. We have partnership with more than 80 to 120 plus MNCs and companies. All right, so I'll be just giving you a short walkthrough on the certification. This is the sample certification here, which will be awarded from IBM Big Data Professional, and you get to work on one live project. And this would be the sample certification from Intellipaat. So you'll be getting respective to all the subjects individually, one certifications would be provided. This is the career service what Intellipaat offers. So once you have completed the training, we'll be assuring you for the interviews, and we also will be giving you the exclusive job portal for all the students who are enrolled with us. And interview preparation would also be there by conducting mock interviews for all the students and offering you tips based on your performance and improving yourself. And even mentoring sessions will also be provided with respect to whatever background you're coming from, how exactly you can start your career in big data. Now, profile building, we have career orientation sessions conducted throughout the entire course once you are participating in it. And it's our responsibility to prepare your resume and update your LinkedIn profile so that you have a attractive profile while we share your resume with our hiring partners while you're at the shortlisting stage. And these are the few companies where our alumni are working at. The course fees would be 56,031 rupees plus taxes, somewhere in the range of 67,192 rupees. And okay, I suppose everything is clear. Anyway, thank you so much for joining the session. I hope you all enjoyed, and I would be looking forward to joining again.
Thank you guys. Have a great time. It was It was a great experience hosting all of you. Let's meet again in the next webinar. Stay tuned to Intellipaat's YouTube channel for further updates. Thank you, guys.